Imagine a star that has died, collapsed in on itself with such unimaginable violence that it no longer resembles anything we know. Imagine a city-sized sphere left behind, smaller than Manhattan, yet so heavy that a single teaspoon of its material weighs more than every building, every car, every human, every mountain on Earth combined. Imagine something that warps space, bends time, and twists the very laws of physics we thought we understood. This isn't science fiction, it's real. These objects exist across the universe. They're called neutron stars, and the deeper scientists study them, the stranger and scarier they become. At first glance, a neutron star might seem like just another dead star, the ashes of something once great. But in reality, these cosmic remnants are some of the most bizarre and powerful objects in existence. They spin at mind-bending speeds, beam out radiation so intense it can be detected across galaxies, and some have magnetic fields strong enough to shred atoms apart. Neutron stars are like natural laboratories, pushing matter and energy to extremes that we could never recreate on Earth. And here's the wild part. As strange as they already sound, the truth is scientists still don't fully understand them. So what are neutron stars really? Let's start from the beginning, at the death of a massive star. When a star 10, 20, or 30 times more massive than our Sun reaches the end of its life, it runs out of fuel. Fusion stops. No more pressure pushing outward. Gravity wins. The star collapses inward, its outer layers blowing off in one of the most violent events in the universe, a supernova. What's left behind is the core. If it's massive enough, it collapses into a black hole. But if it's a little less massive, still crushing but not quite enough for a black hole, the result is a neutron star. Think of it this way. Our Sun, if it ever became a neutron star, would shrink from being nearly 1.4 million kilometers across to just about 20 kilometers across, roughly the size of a city. Imagine all of that mass compressed into something the size of downtown Manhattan. That's a neutron star. And this density, it's beyond comprehension. One sugar cube-sized chunk of neutron star matter would weigh about 1 billion tons. That's more than every car on Earth put together. On the surface of a neutron star, gravity is so extreme that if you dropped a pebble, it would hit the ground at a fraction of the speed of light, releasing energy equivalent to a nuclear bomb. Escape velocity, the speed needed to break free from its gravity, is about half the speed of light. Think about that. A spaceship couldn't just take off from a neutron star. It would need power beyond our wildest imagination. But density and gravity are just the beginning. Neutron stars are also some of the fastest spinners in the universe. Some rotate hundreds of times per second. These rapidly rotating neutron stars are called pulsars. Why pulsars? Because as they spin, they beam out radiation like cosmic lighthouses. Every time the beam sweeps past Earth, our telescopes pick up a pulse, hence the name. When astronomers first discovered pulsars in 1967, they didn't know what they were. The signal was so regular, so precise, that some thought it might actually be from aliens. They even labeled the first one LGM-1 for little green men. Of course, we now know pulsars aren't alien transmitters, but in a way, they're even more incredible. Pulsars are so precise that scientists actually use them as cosmic clocks. Some are more reliable than the atomic clocks we use to keep time on Earth. That precision makes them useful for detecting things like gravitational waves, tiny ripples in spacetime predicted by Einstein and now confirmed by observations. And if that's not weird enough, let's talk about what neutron stars are actually made of. On the surface, you'd find a thin crust of atomic nuclei and electrons packed tighter than anything we know. But as you move deeper, the pressure becomes so extreme that electrons merge with protons, forming neutrons. That's why we call it a neutron star. It's essentially a star made almost entirely of neutrons. But the story doesn't end there. Deeper still, scientists believe the physics gets even stranger. Some theories suggest the inner core could be filled with superfluids, liquids that flow with zero friction. Imagine pouring water into a glass and it just spins forever, never slowing down. That's what may be happening inside neutron stars. Other models suggest the core may contain superconductors, materials that can carry electric currents with no resistance. That could explain why some neutron stars have magnetic fields trillions of times stronger than Earth's. And then there are the most extreme neutron stars of all, magnetars. Magnetars are neutron stars with magnetic fields so insanely powerful that they defy imagination. If you were anywhere near one, even as far away as halfway to the moon, its magnetic field would scramble the electrons in your body and essentially tear you apart at the atomic level. These magnetic fields are unstable, and sometimes they snap, releasing bursts of energy so massive they can outshine an entire galaxy for a moment. In 2004, a flare from a magnetar 50,000 light-years away actually disrupted Earth's atmosphere. That's from halfway across the Milky Way. Imagine what would happen if one went off close by. But neutron stars don't just sit there spinning and glowing. Sometimes they collide. And when they do, the universe puts on one of its most spectacular shows. In 2017, astronomers observed two neutron stars merging for the first time, an event called a kilonova. They detected both gravitational waves and light from the collision, giving us a brand new way of observing the universe. The explosion released more energy than our sun will in its entire lifetime. And here's the most amazing part. Those collisions literally created elements like gold, platinum, and uranium. That's right. The gold in your jewelry was probably forged in the fiery death of two neutron stars colliding billions of years ago. Every ring, every necklace, every ounce of gold on Earth owes its existence to these cosmic smash-ups. But here, where things get truly bizarre, scientists still don't know exactly what's inside neutron stars. The densities are so extreme that normal physics breaks down. Some think neutrons themselves dissolve into quarks, the particles that make up protons and neutrons. If that's true, then inside neutron stars could be quark matter, a state of matter that doesn't exist anywhere else in the universe. Others suggest even stranger stuff, strange matter, made of exotic particles called strange quarks. If this matter exists, it could be the most stable form of matter in the universe. Some theories even suggest that if a single speck of strange matter touched regular matter, it could trigger a chain reaction, turning everything it touched into more strange matter. In other words, neutron stars might not just be weird. They might hold the key to understanding the very building blocks of reality. And then there's the phenomenon of glitches. Pulsars spin with unbelievable precision, but sometimes they suddenly speed up. No warning, no gradual change, just a sudden jump. Scientists think this happens because the superfluid interior of the star suddenly transfers some of its angular momentum to the crust. It's like the star hiccups, but the exact details, still a mystery. Every time we think we understand neutron stars, they surprise us again. They are laboratories of the impossible, where gravity, quantum physics, and nuclear forces all collide. Studying them might help us unlock the secrets of matter itself, of spacetime, and maybe even of the origins of the universe. So what makes neutron stars weirder than we ever imagined? It's not just their incredible density, their terrifying gravity, or their blistering speed. It's the fact that they push physics to its absolute breaking point. They bend reality. They create elements. They blast out energy that can be felt across galaxies. And yet, they're still filled with mysteries we can't explain. Neutron stars are cosmic monsters, but they're also cosmic teachers, reminding us that the universe is stranger, wilder, and more beautiful than we ever dared to dream. And the deeper we look into them, the more they whisper one simple truth. We've only just begun to scratch the surface of what the universe really is.